Hello and welcome to a presentation of multi-channel vibration analyzer system designed, custom-made, and built for pumps and other types of rotating machinery for the power plants, paper mills, chemical plants, municipal water and wastewater plants, and similar. In this example, on the top right side of the right corner of the screen, you'll see a double suction pump driven by a electric motor. On the lower left, you see a motor which is connected underneath the sole plate to a large pump at the municipal waste treatment plant. Or in the middle of the screen, we'll see several vertical turbine pumps at the water plant, driven by electrical motors and monitored at several places. Perhaps on top of the motor, on the side of the motor, at the sole plate, and other locations on one pump or several pumps simultaneously. The system essentially can be made and it's built custom-made by pumping machinery. Here's a website and the phone and the email. Anywhere from single channel to 2, 3, 4, 5, 6, and hundreds of channels. In this particular example, we will cover a 3-channel option as a typical application used for 1 or 2 pumps, and that will be the focus of this particular presentation as an example. The first screen of the analyzer. Analyzer is essentially a handheld laptop computer or similar to which several accelerometers attached through the connection box that can be installed or handheld near the equipment. The user, maintenance technicians, operators, or engineers that are investigating a project can enter their own pictures uploaded to the system, and one of these pictures is displayed here as an example. What do we see on this screen? First of all, there are 3 channels in this particular case we handle, and as I mentioned, we can handle multiple channels. Each channel, let's call it channel 1, perhaps a horizontal vibration of the pump, channel 2 vertical, channel 3 axial, or they could be pump number 1, 2, and 3 at different locations. So in this case, we're monitoring one pump at bearing housing, horizontal, vertical, and the axial planes, 3 accelerometers. The vibration limits can be dialed. In this case, warning limit sets at 0.3 inch per second, and alarm at 0.50 inch per second. And in metric units, it can be switched from English to metric, but we're using English in this example. So if we want to change 0.30 inch per second as a warning to a lower number, here I'm doing it right now, 0.26, 0.25, 0.23, and so forth. So I'm going back to 0.3 for the sake of presentation. The same thing can be done to alarm. We can decrease or increase alarm value, and therefore the system will register. The colors will change from green to red, as you will see in the course of the presentation. Let's see what else we have. We have several option screens, which will go one at a time. There's a main screen, and then each channel 1, 2, and 3 are specifically expanded in the graph. Then displacements also shown, accelerations, velocity, and displacements. The instant replace screen, we'll talk about history file and also diagnostics to see, to diagnose perhaps we have misalignment or unbalance or cavitation, suction or discharge recirculation. So that will be handled in a screen of diagnostics. Now, on the left side, left top side of the screen, we see the contact information for the company. We have a time dynamically updated. Now it happens to be 3:14 p.m. on February 17, 2016. We have a history file. That chart here is a history. And right now, the pump has been running for several minutes, maybe half an hour before we started the presentation. We see amplitude of velocity vibrations versus data points collected, and we'll get back to that a little bit later. And then the control screen here will allow us to go from hertz to RPM or CPM. You can allow us to zoom to a particular frequency of interest. It allows to change spectral windows from Henning to Hammond to Blackman-Harris and other options. We also can change from linear to the dB input. We can delay display to be able to visually look at it and analyze it. And we also have the speed of the pump of the motor entered here as a reference as well in order to analyze harmonics. 1 times, 2 times, blade pass, and multiple harmonics. There's also a trigger button here. I just pushed it. As you can see, the green light went on and the charts got recorded, which you're going to see also in a moment. The trigger is also wired either manually as I just did, or automatically when alarm is exceeded, the trigger will get triggered and the files will be written for the report and for the analysis. So let's go to a main screen. The main screen shows essentially 3 sets for each channel of signals. Acceleration versus time, channel 1, 2, and 3. Then acceleration versus frequency. And the lower channel velocity of vibrations versus frequency. What is significance of that? Well, significance of that is the top screen will allow us to see what happens to the impact types of something went through the pump roughly a couple of seconds, which is not registered very well normally on velocity or accelerations or displacements. Well, let me show you. The pump is running right now. Let me go. I come closer to the pump, and I excite the housing near the bearings for you to see what happens to with acceleration signals. As you can see, the impact is registered on the acceleration scale. And now I am not exciting any longer, and the acceleration becomes normal, reflecting running speed of the pump. And on the acceleration versus frequency, we can see things as bearing faults, usually higher frequency response ranges. And the lower range, lower chart, velocity versus frequency, which is a Fourier FFT transform, will tell us something about unbalance, misalignment, blade pass frequency, cavitation, suction of discharge or circulation. So there's several things we can tell about what's going on with the pump. Is it time to pull it, repair it, realign it, tighten the bolts, and so forth. So let me go to channel number 1, which will show us now same 3 graph, but more expanded to the first channel. Now if I go excite the bearing housing one more time, so you can see here that impact was just registered. The velocity of vibrations now is relatively small, and it shows here in the red numbers 0.07 inch per second RMS velocity. And the spectral analysis shows, if I bring the cursor down here, it shows that 17, here position cursor right at top of the peak, and it's about 15 hertz, and 0.07 inch per second, the first highest harmonic. You can see the second harmonic is about 2 times of the running speed. Well, running speed is about 16 hertz or 960 RPM. Well, while we're at it, let's try to change from frequency into RPM. So if we click here, now the switch went to CPM, and now we can see everything is now in CPM on RPM. It's now at 780, 1,000, about 800, 900 RPM, range 0.07. And if we switch back to frequency again in hertz, now we see frequency display. Now let's see if we want to understand what's going on here in the area. Sounds like between 100 and between 0 and 150 hertz. So what we do now, we'll click zoom. Zoom button gets us zoom to 10 to 20. Why from 10 to 20 frequency? Because on top of the screen we'll see a zoom minimal and maximum set for each channel, actually separately, can be separately. It happens to be 10 to 10 for channel number 1, 300 to 400 channel number 2, and between 500 and 600 for channel number 3. This is just arbitrarily picked numbers as a default. Let's see if I want to go from 10 hertz to 200 hertz. So now once we do this, you can see 10 to 200 expanded, and now we're looking at 120. Let me go to 130 hertz over here. And now we see two peaks at 16 and 120 hertz. 120 hertz, it's probably an electrical noise, 60 times 2. And the 16 times 32, 2 times harmonics, we really don't see. So the bulk of vibrations coming from the 1x fundamental frequency. So might be indicating unbalance. Although it's not very significant unbalance because velocity is relatively small, 0.07. Now, to get the feel for the numbers, what is small? That's entirely different discussion, and we cover it usually in our power school trainings. The next one happens to be in March, and those of you interested to attend, which we'll be talking about these vibrations as well, you can register online at the website that I showed in the earlier slide. But anyways, that's for interpretations of the signal. Now we're talking about basically acquisition of the signal. So channel number 2, similar. It has 0.08 velocity of RMS, and of course acceleration, velocity, and amplitudes are shown here below. Nothing shows on the bottom chart. Why? Because it happens to zoom from 300 to 400 hertz. Nothing happens there. Let me go to unzoom, get entire spectrum, and now of course we see 16 and 120 spikes back in action. Channel number 3 likewise shows acceleration, velocity, and velocity spectrum FFT analysis. Okay. What is also let me, as long as we added, let's talk about displacement. If we click displacement button, we'll see channel number 1, 2, and 3, displacements versus time. Again, if I will go, and they're very small, as you can see in this case, the bearing hardly moves. There is an impact impact on housing by the bearings, but the structure is still pretty solid and stiff, and therefore overall displacements are negligibly small. But if we excite the bearing housing, which I'm going to do now, you can see the values change, and notice what happens with the alarm. You notice an alarm, the warning went in, and then the alarm went in, and as soon as they no longer exciting the housing, alarm essentially disappears. But it triggered the data that goes to the report to capture the chart for a future reporting and processing and further analysis. Okay. Let's see. Now, let's see what this chart shows here. Now, that is basically for 3 channels. Channel number 1, 2, and 3. We have channel number 1, channel number 2, and we can selectively, let's say, unclick channel number 2, and unclick only channel number 0, we call it here, and only start channel number 1. Channel number 1. So channel number 1 shows that we accumulate about 1,300 points in the last 10-15 minutes, with amplitude of vibrations reaching about 0.5, 0.6 inch per second, and that happened a little bit earlier, and those spikes is where I was exciting the bearing housing to simulate a alarm, warning and alarm. So if we want to get expanded view of this history, we're going to click History B, History Big, so to speak. So if I click on this, now you can see that vibration is mostly low, and then it spikes up when we have some impacts, and that impact now stopped. The data is taking quite frequently, but if you want to do it not roughly a second or 2 apart, but maybe once a minute or once every 10 minutes, we can now click here at here. 1 I changed to 10 or 100 or larger number. which is roughly corresponds to approximately a minute apart. 100 will be roughly, 10 times greater, 10 minutes apart. And that will take the data not as frequently and every 10 minutes, maybe once an hour, to show you a trend over days and months and weeks. And then you can always look at this trend. You can go to the zoom feature and you can zoom on this portion of the screen. As I'm doing right now, you can see what happened between points 1085 and 1090. And later on, I'll show you a lookup graph, another option that you can go and see on that graph which points 1085 to 1090 correspond to which days, times, minutes, and seconds. Okay. Now the next one we will look into is the instant replay. We go to instant replay screen. And we'll turn with the switch display on. Here it is. We have options for replay of velocity on channel number 1, velocity 2, and velocity 3. And we can build custom-made any other parameters or any other number of screens that might be of interest to this particular or that particular customer or the plant. Some of you might be interested in more detailed analysis of spectral signals, so we can add velocities of other channels, accelerations, and some might be interested in overall trend, more expanded view. We can do that too. But let's say in this case, we will now I'll push this button, which is a write V1, velocity 1 to the playback file. I just put that, and that is being written. It's writing it into the file as we speak, while the data acquisition continues taking the data. Well, if I stop it now and I want to replay it, I just hit playback. You can see that history just replaying what happened in the past. If I want to go replay it slower, I can put more milliseconds delay. If I want to go real fast, I can increase replay time, and you can see the file replays, reaches to the end of the file and continues replaying in order to analyze what's going on, to give you a feel what was happening. So you can see that amplitude was changing from 0.5 to minus 0.5, which is roughly maybe 0.3 RMS value in this instance for velocities, for channel number 1. Okay, then we can do the same thing for velocity on the channel 2. Let's see if I write the V2, I just push the button. And then I stop it quickly and do a replay. We do a similar replay on channel number 2. That's instant replay. Now, next one is the diagnostic screen. So if I click on diagnostics, we have 960 RPM entered as a running speed. Now we have to correct it to 960. And you can see that on the channel number 1, the first harmonic at 0.27 inches per second now is at, and you can see 0.26 inches per second, which is roughly on a trend chart somewhere in this area. Okay, and it happens at about 16 hertz. The peaks are so close to it, they just changed to 0.28. The peaks are so close to each other that the second peak at 0.22 is very close to 0.6. It's a washed out peaks. So and then because we are so close to 1 times running speed at the maximum, there's a message diagnostic that says unbalance is due to 1 times component. We recommend monitoring magnitude and trending because something is happening. Perhaps impeller lost part of its blade, or the shaft lost a chunk of it, rotor lost a chunk of it. Bolts loose on a coupling connecting intermediate shaft for vertical turbine pumps, and that unbalance is now registered and presented by diagnostic. However, the warning and alarm are still low. But let's see if we change the warning to, now I made it 0.15, so warning is on. And if alarm is at let's say 2, 0.19, 0.18. Now the first channel is alarm if we change, obviously, warning and alarm values. Channel 2 and 3 do not show warning and alarm because the limits, here I increase the limit for the alarm on channel number 3, and now channel 3 is not in alarm state. So we can change its values depending on the vibrations institute specifications, but this is just for example. So that this diagnostic screen can pick up unbalance, misalignment, recirculation, cavitation, bearing faults, and display it in a way that maintenance and operators can relate to what's happening with the pump and help them make a decision what to do with the pump. Well, let's say I will artificially change the speed from 960 RPM, let's say to half of that, 480 RPM. If I make it 480 RPM, now the pump thinks that 480 RPM, which is 8 hertz, is roughly half of running speed, or running speed, the maximum harmonic. Let's go to channel number 1. See maximum harmonic at 16 hertz. Go back to diagnostics. That's double of running speed of 8 hertz. If it was 480, I just artificially told the system the pump is running at 400 RPM. You can see the diagnostic now is different. Possibly there's a shaft misalignment because there are 2x component. Recommend monitor magnitude, and probably shaft realignment may be required in the future. That's another option that might be helpful to actually tell the maintenance and operators what's happening with the pump, and not simply keep it running until it fails catastrophically. So that is the set of screens, and of course we can custom build additional screens based on the input from the field, what people need. You can see the range of frequencies or RPM or CPMs. You can go by RPM or frequencies. And if I look at the charts, let me snap another the pump keeps running. Let me alarm the pump a little bit more by exciting the bearing housing. As I do this, watch what will happen to the trend. You can see how everything went to the alarm, and actually let me expand the history of B trend. You can see what happens right here. If I zoom into what did I do here? That is, all 3 channels went up to a quite high, almost 1.2 inch per second vibrations, exceeding alarm. That's why the signals went red. And of course now I no longer the excitation force is gone. And therefore, the magnitude back down to, let's say, normal, about 0.2 inch per second. Okay. If we want to delay the display, let's say I want to look at this, we can always turn this from 10 milliseconds to 2,000 milliseconds delay or more. And now you can see how I'm freezing the display in order for me to get some more online eye analysis of what's going on. So I'm going back to 10 milliseconds, which is more rapid display. And one more time, let me push this button and click the graph. And that graph is essentially a copy of this charts in a different file. The data file is also written in the Excel spreadsheet, so you can download it and analyze and manipulate it by the engineers if analysis is needed. And therefore, it gives you a good capabilities to examine 1 pump, 2 pumps, many pumps by adding 1, 2, 3, 4, 5, and dozens of channels if required. Now, there's also a little neat feature of that's for the essentially a troubleshooter or for system lookup. This is lookup button. If I push this button, I just did it. The lookup files come in. And this is just internal files to tell you in which drives different graphs are residing, which charts are keeping the history of vibrations, which pictures. I know, of course, you can replace pictures with different pictures, and therefore your project, all you do is put into a directory a different picture, and that picture gets pulled by essentially this first panel, which is a project photograph. It will be a different pictures depending what your project is doing. Well, if any questions, please let us know, and put my introductory slide back on, which is over here. Again, multi-channel vibration analyzer, system for pumps and other types of rotating machinery for power plants, municipal plants, water, wastewater, chemicals, paper mills. Contact me with any questions. Our company name is Pumping Machinery, with a website, pumpingmachinery.com. The phone number is 770-310-0866, and my email here as well. Until we talk again, look forward to hear from you. And as we always say, keep on pumping.